Alright guys, we're here. Chapter 12. Are we ready? I'm certainly not. Alright, so today we're going to be doing 12a, the inverse matrix. We use a to the power of -1. That means the inverse of a. And to find an inverse, we must have a square matrix. Okay, so we say the inverse, for the inverse to exist, the matrix must be square. Before we look at how to find the inverse of a matrix, it's necessary to recap the concept of an identity matrix. So these are the ones we have a symbol I for. So an identity matrix is a matrix that consists of ones along the diagonal and zeros everywhere else. Like so. So an identity matrix behaves like the number 1. When we multiply a matrix A by the identity matrix, matrix A is unchanged. So let's look at the following example. So if A is 3, 10, 2, 5 and I is the identity matrix, calculate A multiplied by I and I multiplied by A. Let's just do it on our CAS and make comment on your findings. All right, let me whip out my CAS. Okay, so Math 2, square matrix. I'm going to go 3, 10, 2, 5, and then multiply it by the identity matrix. There we go. And press enter. So we get 3, 10, 2, 5. Whip out our CAS again. This time I'm going to switch up the order. Press enter. And we get the same thing. There we go. So that is just proving that that identity matrix acts in the same way as the number 1 does. So it's multiplying it by itself, and the order is not important. Okay. So the inverse of a square matrix, A, is written as A to the power of -1, and where A times A to the power of 1, to the power of -1, or equals A to the power of -1 multiplied by A, which equals the identity matrix. So the order is not important. Inverses are only defined for square matrices, and it's a way of, we're going to be using it as a way of undoing a matrix. Okay, just like inverse operations. Such. For example, show that the matrices 3, 7, 2, 5 and 5, -7, -2, 3 are inverses of each other. So if they are inverses of each other, then if we multiply A by B, then we should get 1, 0, 0. Okay. In either, no matter which way we multiply. So we can chuck that into our CAS. Alright, so I've entered A and B. If I press enter, look at that. Identity matrix. If I switch them up, it's B multiplied by A. Get rid of that third one there. Press enter again. There we go. We get our identity matrix. Okay, so as the two matrices multiplied give the identity matrix in either order, we can say that each matrix A and matrix B are each other's inverses. Alright, so now we have the determinant of a matrix. So this determines whether or not an inverse does exist for a matrix. So many square matrices do not have inverses. To see why, we need to introduce another new matrix concept, and this is called the determinant. Okay, and this is a number associated with a square matrix, so it has to be a square matrix. To find the determinant, we're going to multiply along the leading diagonal. So here is pictured in red. So A multiplied by D, and then we subtract B multiplied by C, and that gives us the determinant. So if we have matrix A equals A, B, C, D, we write det A, so det open bracket A, close bracket, equals these two terms, take away, oops, I should do it in red to color coordinate, these two terms, take away these two terms multiplied. Alright, example A. Calculate the determinant of the following. Okay, so we have here, I'm going to use pink and blue as we have in our notes. So to calculate the determinant, so it's matrix A, so we're going to have the determinant of matrix A is equal to 3 multiplied by negative 3, subtract 4 multiplied by 2. Okay, so 4 multiplied by 2 is 8. 3 multiplied by negative 3 is negative 9. Also just put that straight into my CAS. What's going on? And that equals, do you know what the problem is? I'm writing in my Oodie. This always happens, doesn't it? Negative 9 take away another 8 is negative 17. Okay, let's find the determinant of the next matrix. So matrix B, so we have the determinant matrix B is equal to 6 multiplied by 2, take away 3 multiplied by 2. Okay, I put that straight into my CAS, and I get 6. And part C, so the determinant of matrix C is equal to 4 multiplied by 6, take away 8 multiplied by 3, 24 take away 24, which is 0. Now, looking at the next sentence, for any matrix that has a determinant of 0, so the determinant equals 0, it is impossible for an inverse to exist. So a matrix with a determinant equal to 0 is called a singular matrix. So we can't do anything more for matrix C. Looking at the next example, if the determinant of 5 negative 3x3 is equal to 21, what is the value of x? Okay, so it's asking us the determinant, but this time it's told us what the determinant is. And here, here we have an unknown. So if we carry on as usual, so our determinant is equal to 5 multiplied by 3, take away negative 3 multiplied by x. They've told us that our determinant is equal to 21. So 21 equals 5 times 3, take away negative 3 times x. Just be careful with those negatives. Remember, this negative here is part of the formula. Okay, so that's why we've used brackets. brackets are always our friends. And I've just picked up my actual calculator, which you of course can't see. So let's whip out my electronic CAS. And I'm going to enter that in. 5 times 3, take away negative 3 multiplied by x, and that is equal to 21. Now I'm going to highlight interactive advanced solve. It's going to be doing its thing. It's thinking. Is it or is it not? Try again. Whoops. Interactive advanced solve. There we go. Press OK. And it tells me that x equals 2. Don't know why we've got it in highlighter there. Maybe just to emphasize. X equals 2. There we go. Great multiple choice question on an exam. Alright, so now we've looked at the identity matrix. We have looked at how to find the determinant. Now we're going to look at how to calculate the inverse of a matrix by hand. So to do that, there are a couple of steps. So step 1 is we need to find the determinant. Okay, so this here is our determinant. And that determinant is going to be 1 divided by the determinant. And that is going to be a scalar multiplication of the matrix. Now you'll notice here that our A and D have switched places. Okay, so to calculate this by hand, A and D switch places, and B and C stay in the same position, but they change signs. So if B was positive, then it becomes negative. If it was negative, then it becomes positive. So B and C stay put, but change signs. Positive goes to negative, or negative goes to positive. Okay, so let's see how we go with this next example. First up, calculate the determinant of A. So we'll do 6 multiplied by 3, take away 2 times 8. So the determinant of A is equal to 6 multiplied by 3, take away 2 multiplied by 8. Chuck that straight into my CAS, and I get 2. If I want to find the inverse, the determinant did not equal 0, so that means the inverse, so therefore the inverse will exist. Alright, so to find the inverse, so it'll be A to the power of negative 1, and that is equal to 1 over the determinant, so in this case it's going to be 1 over 2. Our 6 and 3 switch places, so our 3 is going to be here and our 6 is going to be here, and the 8 and 2 stay put. If it was positive, it becomes negative. If it was positive, it becomes negative. Okay, and then we perform a scalar multiplication. So we've got a half each of those numbers. So we're doing this on our CAS. You might want to flick between the standard and the decimal button because sometimes your decimals are going to get out of hand. And so we will have 3 on 2, negative 4, negative 2, oops, no we won't, negative 1, and 3. There you go. Alright, let's have a look at determinant of B. So determinant of matrix B is going to equal 8 multiplied by 2, subtract 2 multiplied by 8. So if you have 16, take away 16, that equals 0. So you can say, when asked to find the inverse, determinant of B equals 0, therefore inverse does not exist. Cool, so that's that question finished. Let's look at the next one, part C. Let's find the determinant of matrix C. So we'll have 2 multiplied by 7, take away 5 multiplied by 3, and that will give us -1. So our inverse does exist. To find the inverse of matrix C, we're going to do 1 divided by the determinant. Remember, it goes from here to down here. So 1 divided by -1 is just going to be -1. And then we switch the 2 and the 7, and the other two stay put, and we change whatever signs they had to the opposite. Okay, so 1 divided by -1 is just the same as multiplying everything in our matrix by -1. So we will get -7, 5, 3, and -2. Awesome. There we go, that's page 282. Moving right along. So multiple choice question, the inverse for the matrix 1x, -1 and 2 is. Okay, so 1 divided by our determinant, and then it's going to be the 2 and the 1 switched. X is positive, so it's going to become -x, and -1 is negative, so it's going to become +1. We didn't need to write that positive out the front there, Miss Upjohn. Okay, so far we can cross off part D. Now let's find the determinant, which we've been doing in orange. So we'll have 1 multiplied by 2, take away x multiplied by -1. So if we simplify that a little, we've got 2 take away -x. If we think back to learning about integers, if we have a negative take away another negative, that is going to become a positive. So we get 2 plus x. So we're going to have 1 over 2 plus x, 2 -x, 1, 1. So now we're looking to match. It's not A. It is 1 over 2 plus x, 2 -x. Looks like we found a winner. So here, part B is our answer. Option B is our answer. Moving right along. Using a CAS calculator to determine the determinant and inverse of a matrix. Alright, so if we enter a matrix into our CAS, okay, so we've got a square matrix in there. I'm going to highlight. So this is to calculate the determinant. Remember, it isn't necessary for you to store every matrix that you're going to use. If we go enter the matrix, highlight the matrix, go interactive, then we're going to go matrix, and then we are going to go calculation, and then we are going to go determinant. So that tells me the determinant of that matrix is -5. Okay, so we'll write those steps down. So we highlighted the matrix. Well, first up, we entered the matrix. Whoops. Then we highlight the matrix. Then we went interactive. Matrix. Calculation. And then det, which is short for determinant. Okay, and that will give us the determinant of a matrix. To find the inverse of a matrix, it is as simple as entering that matrix and then putting it to the power of -1. So if I whip out my CAS and use the same matrix again, I'm going to highlight it and drop it down here. I can use this button here, just one of them is updrawn, and to the power of -1, and press enter. We've got decimals here, and that's because the decimal button here is selected. If you click that to standard and press enter again, and then it will give us the fraction form. Okay, so nice and straightforward. So remember to flick between decimal and standard, and there you go. So at the bottom of page 283, there are 2 examples there that you can have a go at to see using your CAS and see how you go. I'll put the answers up. So pause now and I'll put the answers up. And there you go. So now you should be able to work through exercise 12A. Have fun.